Welcome to the Power of ERDC Podcast. I'm your host, Tim Reeves, and joining us today is Jacob Stasiewicz, a master's student at the University of Delaware, who, in addition to his studies, is literally writing the book on how deploying robotics in response to natural disasters. Jacob has worked with ERDC the past few years at our field research facility in Duck, North Carolina, the premier coastal engineering research facility in the world. This summer, Jacob led the SandHound Project, an effort to understand how quadruped robots, or robot dogs, could be used to survey coastlines following hurricanes or coastal storms, or provide our military critical coastal information for possible amphibious landings. Jacob, thanks for joining us.
Thanks for having me.
Hope we didn't get you up too early for this.
No, you're good.
No, we're good. Okay. How much coffee so far?
Just one cup. Second cup, maybe after this.
Okay. So before we get into the SandHound Project and your work there, briefly tell us why you decided to major in coastal engineering. I know you got your bachelor's at University of North Carolina, Wilmington. Why did you decide to chase that particular major?
Yeah, so a little background. I was born and raised in North Carolina. Growing up, my family had a beach house in Emerald Isle, North Carolina. So the coastal Eastern North Carolina was kind of a second home for me. I grew up kayaking in the Sound, just exploring the Sound all day, fishing, sailing, surfing, all the coastal activities. I went to summer camps every summer down there. So it was a place that was pretty near and dear to my heart, just Eastern North Carolina. When I got to UNCW my freshman year, I wasn't sure what I wanted to major in. I was thinking environmental science or marine biology, but neither felt exactly right, just because I kind of have always had this tinker mindset, like taking things apart, building things. You know how that goes. And they didn't have an engineering program at the time. Well, 4 weeks into school, Hurricane Florence hit, and it was an especially nasty hurricane. It set off the coast of North Carolina for like 2 whole days almost. So I was out of school for 4 weeks because of that hurricane. During that time, I would drive to different places in Eastern North Carolina, like Beaufort, Oriental, Emerald Isle, the Outer Banks, helping with storm cleanup. And just like some of the damage I saw was beyond belief. You would see entire 2-story homes moved into the middle of, tobacco fields, entire roads, bridges gone. I went and visited a camp I went to when I was younger, and there was like 100 foot of their shoreline just gone into the river. The craziest thing I saw was like a 25-foot sailboat wedged up 15 feet above the ground and between some pine trees, because that's how high the storm surge had gotten in parts of coastal North Carolina. So when I got back to school, like 2 months later, they announced a coastal engineering program that they're starting, and it's going to be the first of its kind in the country, the first undergraduate coastal engineering degree. So it's kind of like the stars aligned, and that was just like the perfect degree for me. And that's where I started with coastal engineering.
So how are you blending that experience and the expertise of that tinker mentality you said now to kind of how you're blending that robotics and coastal engineering together?
Yeah, so even when I was studying at the University of North Carolina, I was in the coastal engineering major, like we talked about. But most of my focus was machine learning and building various sensors and embedded systems for coastal applications. So once I finished school, I knew I wanted to get my master's degree, but I knew I didn't want to go back for coastal engineering. I wanted to do something tangent that would work with coastal engineering, like machine learning, robotics, something of that sort. Um, so robotics, like really, I landed on that because it ended up serving as like a perfect sort of platform for a lot of these systems and these machine learning models I had been working on, where the only problem was everything I had been working up onto that point was stationary and, couldn't move around on the beach or couldn't, or even underwater. So that's kind of where like the blend between coastal science, machine learning, and robotics comes from.
So SandHound Project is a collaboration between the University of Delaware, where you're at now, and ERDC. How did this research project come about, and what are some of the things you are hoping to learn or have already learned?
Yeah. So the research project came about probably a year ago, or about a year and a half ago. I was working with the SandSnap team, which is ERDC initiative. It's a citizen science project, basically, where users can place a coin on the beach, snap a photo of it, upload it to a website, and it tells you the grain size of the beach. Um, and I kind of wanted to continue doing some of that grain size work. I had mentioned to some people on my team that I wanted to go back and get my master's in robotics, and they suggested I reach out to this professor at University of Delaware. I reached out to him. I kind of told him what I was interested in, what I was thinking about, and he was like, "Well, I've been thinking about using a quadruped for beach surveys." And so we got to talking, and everything kind of lined up perfectly with that. So going into this project, the main goal was to see how well does a quadruped just work on the beach in general. How fast is it? What are its limitations? Where can it go? How well does it work in, extreme heat, whatnot? And so far, we found it works a lot better than what most people would have expected. It works a lot better than beach rovers. It can move about as fast as a human walking on the beach. It works completely fine in the heat. It can even go up to its I guess its knee joints in the water. It's got a lot of versatility on the beach, and it exceeded our expectations.
So let me ask you a question. So you have taken this quadruped, and this is a commercially available technology. This is not something you build, but it's something that's commercially available, and you're testing. What were some of the, I guess, some of the looks that you got on this beach? And for those who don't know, the field research facility is in Duck, North Carolina, like we said, on the Outer Banks. And while there's a beach that's set across that's for testing, it's publicly accessible. People walk there the whole time. So what were some of the looks you got as you were taking this quadruped robot up and down the beach and up the dunes and in the water?
Yeah. It's, I mean, it's a robot dog on the beach. So everybody and their mom comes up and talks to me. It was interesting, the responses I got. Most of them were just people curious, taking videos, asking what it could do. I always got a lot of questions. Can it jump? Can it sit? Can it bark? Like anything a normal dog could do. Um, I had plenty of people that were curious, but they didn't want to go near it out of a little bit of fear there. Um, every single child that saw it was just like completely enamored. Like they would run up to it and try and run around it and ask me all sorts of questions, ask if they could control it. So over the month I was in the Outer Banks, I quite literally probably got asked about it like at least a couple hundred times. It got to the point where when I would go out to the beach to test it, I always make sure I have somebody with me that knows enough about it to just answer questions. So like I could focus on doing whatever the mission was that day, and they could talk to.
You had your own spokesperson,
Yeah, I did, because it's like I could, especially when I'm running LiDAR, I don't want it really sitting in the same spot. I want to keep it moving, and so I would just have to focus on that. I love talking to people about it, and I like that people are interested in it. I was also very surprised the amount of people that came up to me and they're like, I work for so-and-so company, and our company actually just purchased a quadruped for so-and-so work. So it's definitely gaining popularity, and people across multiple industries are seeing there is a use in quadruped like systems for, obviously for coastal science, for manufacturing, whatnot. But everybody that did talk to me was pretty much of the same opinion, like, oh, they're going to be everywhere. Like, are we going to start seeing this on the beach every single summer? And I was like, you might.
Yeah, good luck. You might. So let's talk about that. Yeah, the use you just talked about goes into the next question. As you put the robot through its paces, what do you think the future of this type of system is as it relates to the Army, to the Corps of Engineers, and emergency response organizations?
Yeah. So the nice thing about these quadrupeds is they've got this bio-inspired design. So they have 4 legs on the ground. They walk like dogs. So they're really versatile. You can use them in a lot of environments. I do think the Army is going to adopt quadruped style robots for a whole slew of purposes. Right now, we're working with them to have these quadrupeds actually as like the first landers on a beach, to be able to map it, do measure geotechnical properties, and make sure the beach is safe for troops to land. For civil applications, I can easily see local municipalities buying a dog kitted out with survey gear that is surveying the beach once weekly, maybe even daily. It leaves from a certain spot, goes surveys the beach at either low tide, and then goes back to its charging port, just so that these local municipalities have that vast amount of data where they can make decisions for beach renourishment, or whatnot. I think, and then in general, I think we're just going to see them adopted as kind of like a workhorse or like a mule for a lot of other industries, just being able to pull things around, carry equipment, and make decisions.
Let's talk a little bit more about, you say, the survey stuff. The robot you were testing, obviously, is from the University of Delaware. I think you had a nickname. What did y'all name it?
Snoop.
Snoop. Okay, so
Yes.
that's a very formidable name. Makes people, is very, imposing. But talk about, it wasn't just the mobility of this particular robot you were testing. It was also a suite of sensors, correct? What were some of the things that you had on the actual platform itself that you were testing, and kind of why?
Yeah. So the robot comes equipped with, I believe, 12 cameras. I should know this off the top of my head, but it has side-facing cameras, 2 front-facing cameras, 2 rear-facing cameras, has 2 downward-facing cameras, and then like 1 for like downward into the front and 1 for downward to the back, just to see the ground in front and behind it. And then in addition, it has 2 GPS units on it. Obviously, it has an IMU, so we can know its pose and how fast it's moving. So what we added is a separate high quality downward facing camera to capture pictures of sand. And then we're running these images through a grain size estimation model, so we can figure out the grain size of the beach, which is important for a lot of reasons. The second sensor we added is we added a LiDAR unit to the top of it. So this LiDAR unit, we want to compare how well a LiDAR unit mounted on the dog works compared to traditional survey methods, which would either be, a LiDAR mounted on an ATV, or even a dune mounted LiDAR like they have at FRF facility. And then we have a time of flight sensor on the front of the dog. This is just to know the distance to the sediment bed. So the 2 main big upgrades we did were the LiDAR unit and this downward facing high quality camera. And right now we're working on a cone CPT, what is called a cone penetration test. The way to think about this is it's sort of a rod with a pressure gauge that presses into the sand, and we can get some density measurements from that. And so that's important, knowing the geotechnical properties of the beach, especially for military applications like landing craft. And the reason that we added all these sensors is we really wanted to make this dog one central unit that can do, 5 to 10 different things, measure a beach in its entirety, not just, the basic surveying of walking around with the GPS, but getting the LiDAR scans, the grain size, doing CPT test. And then with these side facing cameras and downward facing cameras, we also capture a lot of images, and we're going to be training a lot of machine learning models to identify things like scarping on a beach, identify where like the swash zone starts, identify people, vegetation. And the idea is we could use some of these machine learning models and possibly do some rescue operations with it as well, or at least some identification, if you will, of either drowning swimmers, hazards on the beach after a storm, whatnot.
So we said this was your testing and work was with the FRF, or Field Research Facility. What was, and that facility in itself is very unique. What about its people, its facilities, the equipment it has, the space it has, what makes that so, I guess, perfect to test what you're doing and made that, I guess, testing successful?
Yeah, so the FRF facility it's the perfect place for testing any coastal equipment for a few reasons. The number one reason for me is just the people there. There's any type of coastal scientist or coastal expert you could think of. You got your coastal surveyors, you have coastal modelers, geologists, field techs, oceanographers, marine biologists, on and on. And then you have a whole support staff that can help you out in the workshop, build equipment, fix equipment. So that's like the most important part. I would be dropping in people's offices all day long, asking them just like little questions, like, I need to go to the electronics guy, figure this out, or I need to go to the surveying guy and ask him how I should mount this. So that was a really important part of my research, is just having that like vast amount of knowledge just collectively from everybody there. Secondly, the facilities are, I mean, you walk out the office 20 feet and you're on the beach. So the facilities themselves are just where they're situated is perfect. There's, I think, I want to say about a mile of beach in front of the FRF facility it's a public beach, but no one goes to, lounge there. Mostly everybody's either fishing, surfing, or walking down the beach. They have a mile-long pier that's got all sorts of equipment attached on it. They have, like I said earlier, a dune-mounted LiDAR. So they're doing LiDAR scans every 30 minutes of the beach there from the same spot. They have a large like fire tower with a bunch of cameras attached. They have ATVs. They have two really cool machines. One is called the Lark. It's like an autonomous or amphibious vehicle that can just drive on the beach, drive into the water, and drive back.
It's a playground.
It's
a playground.
It's exactly. It's a playground for coastal researchers. Right. You have the Crab, which is a giant like 3-wheeled tripod that can roll into the ocean and go do surveys and core drills and whatnot. So they have like any type of equipment you could want or even imagine for coastal research. And then lastly is, because the facility has been around so long, just like the vast amount of data they have on the beach is crazy. Like, I would not be surprised if it is the most studied beach in the entire world. It's definitely top 3, top 5. But I would not be surprised if just by sheer amount of like data, like terabytes of data they have on this beach. So I can go and, if I'm doing a LiDAR scan with the dog and I'm kind of curious how some part of the beach looked before a storm, or if there's a sandbar here or there, I can go find that data and just look it up. Like they have the past 20 years plus of data. If I need to know grain sizes in specific spots on the beach, I can just go talk to the relevant person and they have the data already on file somewhere, or even the physical samples. So the whole facility, just the people, all the equipment they have, and then just like the history of the field research facility, make it the best place to develop and work on any sort of coastal robotics application or any coastal application. And there would be multiple days where it makes it really fast to test things. So like there would be multiple days where, or there would be days where I could break something like I inevitably do on the robot. I would fix it. I would change some code a little bit and I would take it out to the beach and test it again. And I could do that 4 or 5 times in a day, where I'm, at University of Delaware, I'm 2 hours away from a beach. So, and the beaches are crowded and fairly small, and I would have to take a bunch of equipment with me. So just having that whole facility and the beach right there was like perfect for rapid prototype testing.
I think we were talking earlier one time, and not to make light of it, but I think we talked today. It was almost easier to check the dog out from the University of Delaware than a book from the library. So what were some of the, like, did they give you some rules of engagement, like, hey, don't do too much with it, or just go and do all you can with it from the universal folks?
I think, yeah, the university folks were very lenient with how I used the robot. And again, this is just due to what the Army Corps actually wants to know with it. We really were stress testing it in a sense for the beach. Sam gets all the joints. Like there were some days we were out there, it was like 105 degrees. You got the salt air. You got steep dunes. So like we were really not trying to break it, but we were finding its limitations. I think the school knew that to begin with, which is why they were so lenient. But up to this point, like they have done plenty of research with the dog, but they really haven't put it into any demanding environments where these type of systems are going to need to be pushed if they're going to be useful in the future. So it came back with some scratches and some dings, but all works fine. Nothing's broke on it.
Nothing's broke on it. Yeah. So as you talk about the future of coastal engineering and coastal sciences, how do you see the incorporation of robotics and artificial intelligence and machine learning kind of advancing those sciences and engineering fields?
Yeah, so I think the biggest thing that we're going to see is just a lot of autonomous solutions. So what I mean by that is I think going forward in the future, we're going to see like 1-man dredges, 2-man dredges, like very, autonomous systems where there's going to be little human input. We're going to see fully autonomous ports. We're going to see a lot of surveying done just with drones or these quadrupeds where there's no humans involved in the loop, no human error introduced. So I think like the intersection of robotics, machine learning, and coastal engineering in the future is going to be like there's going to be vast arrays of sensors all over the place collecting data, communicating this data back to some central hub, which is going to have machine learning models on it to make decisions. And then these machine learning models are going to inform either how these robots act in the environment, what they need to do, what parts might need to be cared for a little more, or even how the robots are going to navigate these environments. So I think, it's not just coastal engineering. Like everything in general is going on this trajectory. I think the machine learning part is kind of like the piece that pulls the robotics and the coastal engineering together, because it really is like humans, we just can't deal with the amount of data we're getting from these environments, especially for coastal engineering. There's plenty of data sets out there that have been made that nobody's just even bothered looking through, but machine learning models can be trained on them and make decisions with that data pretty quickly. So yeah, it's going to be interesting, but I think it's going to be a lot of humans out of the loop work, mostly autonomous systems capturing that data and doing whatever a work they need to do.
Yeah, and you're helping write that book, write that future for that. So what's next for you? So, what is, as you're blending this passion that comes from having seen, childhood camps severely damaged by hurricanes, seeing family, vacation spots nearly washed away. I know we talked about the recent storms that came up the coastline that you had to spend time cleaning up. Yes, you did some surfing, I know, but you cleaned up. But you're seeing that passion. What's for you? How do you blend that passion together and to what you do next?
Yeah, so I think for me going forwards, starting my own company has always been kind of the play and has always made the most sense for me. So after I finish grad school and get my master's in robotics, I'm going to continue working on a previous project called Instagrain for at least a few years. So Instagrain is a standalone camera that I've been working on for about 6 years now. It does grain size analysis on board. It takes less than a second to do. So the alternative to that would be you go to the beach, you scoop up some sand, take it back to a lab, shake it through, a sieve machine or a cam sizer. And then maybe if you're lucky, like 3 hours later, you have the grain size measurements. But for this system, you can just take this physical camera to the beach, place it on the ground, take a photo, do it hundreds or thousands of times and have those grain size measurements instantly. So that's something I'm working on right now. I would also like to dive a little more into the robotics once I graduate. We've talked about it. I've really had this idea of a crab robot. I think it would be perfectly situated for coastal applications for two reasons. Just like biomimetic, bio-inspired design for robotics is the future, because evolution acts as this reinforcement learning for us. Like evolution has already decided the best shapes and orientations for organisms for specific environments. It's also one of the reasons you're seeing these humanoid and these quadruped robots become so popular now is because you can take a video of a dog or a human doing a task, and you can use that video as training data for these robotics. So like that's a big a pro, and it speeds things up significantly. So going back to the crab robots, crabs have like evolved that specific body morphology, I think like 8 different times. They've converged on that body morphology through evolution, even though they're not coming from the same branch. So obviously it's an optimized body morphology for these coastal environments. So I really do think that crab robots would be novel, and I think it would be neat. And I want to say it would be, I think it could be the most optimized for the beach. They can work on land, underwater, climb things, swim around, dig holes. So it could place all sorts of sensors, get all sorts of information. I don't know if the motors, the current hardware is there yet, but I'm thinking it will be in the next year or two, just because of how fast robotics is moving right now. It's kind of having its AI moment, so to speak, like when ChatGPT was introduced a few years ago. That's very much what robotics feels like right now. So yeah, going forwards, I do want to stay in the coastal realm. I don't want to be, so to say, a coastal scientist. I would like to build equipment to help coastal scientists and to help these coastal communities. Obviously robotics and machine learning, like we've talked about. And then, kind of stay stay around the coastal sciences my whole life and start a company, if not a few, is I think the plan right now.
Well, listen, as we end, if you thought you got crazy looks with a 4-legged robot going up and down the beach, I can only imagine what the looks would be seeing a robot crab coming out of the surf and the looks you would get from people. So listen, Jacob, thank you for the time today. Thank you for being on the Power of ERDC podcast. I think it's a great conversation. One that, yes, admittedly we've had before. I know there's a, in the show notes on the website, poweroferdicpodcast.org, there'll be a link to a video that was done on the SandHound Project, so you can go out there and see it, and see kind of some of the looks that he and his team got, and the area in which they operated, Duck, North Carolina, and the field research facility. So, Jacob, thanks. Best of luck with your studies and with the future of the crab robot as well. We hope to see it soon. So, with that, I say thank you to all of you for joining us as well. We will see you again next week. Thanks.
This effort was funded by the Defense Innovation Acceleration Containerized Agile Expeditionary and Rapid Beach Preparation, or CONAIR, project under Spiral 3, creating technologies for expeditionary joint logistics over-the-shore operations. Funding was also provided by the U.S. Army Corps of Engineers Geophysical Computational Modeling Strategic Research and Development, or GCM, to obtain terrain data when other means of data collection might be unavailable.